This is the hole wizard. So in order to use the hole wizard you need some existing geometry in the part. In this case we've created a small box with a wall thickness to it and a base but no top, and we're going to put some holes in one of the sides of the box here. So if you select the hole wizard, and then this opens up the main interface of the hole wizard. So I think what we're going to do to begin with is we're just going to create a standard hole. So some of the options in here, when you just select standard hole, it's asking for a units standard to begin with. So whether you want an inch standard or a metric standard, there's lots of different standards in here. So I think what we'll use is an ANSI metric, and then within there there's also lots of different sub options. You can create holes for dowels, you can create holes that are just plain drill sizes, helicoil, tap drills, screw clearances, tap drills. I think we'll just select the drill size option, and then we'll select the size that we require. So these should all be sizes of drills that you can buy that are freely available. And then when we've selected all that, we'll select how deep we want the hole to go. So whether we want it to go through all surfaces in the part or to a blind depth. I think what we'll pick is a blind depth here, and we'll put a figure in there just to begin with. We'll put 10mm in. Some other options in here, you can have a countersink on the hole. So by default it takes the diameter of the hole and adds a certain figure onto the end of that. By default it's 0.05mm on diameter, so that's 0.025 on either side. I think for this example we'll leave the countersink on, but we'll increase it a bit so it's a little bit more visible. So I think we'll put 0.8, bigger than the diameter of the hole. So we've set all those options that we want in there, and what we need to do next is click on this position tab, and then what it's saying is select the face for the hole or slot position. To create holes on multiple faces, click 3D sketch. In this instance we don't want to use a 3D sketch, we just want to select this face here, and what it's doing is it's showing us a little preview of what the hole's going to look like, and if we click somewhere on that face it puts the first hole there. We can continue clicking if we want and placing holes, and then when we've done, if we just hit escape, and it's given us the preview of all these holes. So you can see in this instance we gave it a depth of 10mm, and it's previewing where the drill would get to reach that 10mm. So you can see that's more than deep enough to get through this wall thickness as it stands. So we could probably back that off a little bit. If we manually enter 7mm, you can see that the preview updates. So we can assume these walls are around 6mm. Maybe if we enter 7, just to be on the safe side, and then click on OK. You can see that the holes have been created. What we didn't do, and what we will now do, is go back into the feature, click on position again, and put some dimensions on these holes. So you need to pick some existing geometry and lock them down so that you have control over their positions and nothing untoward is going to happen when you start changing geometry. So you would lock all these holes down, whether that be for from the edges of the box, as I'm doing here. Or maybe from a center plane. However you do it, you want to see this fully defined at the bottom here, which means you've defined exactly where they're going to be. So let's OK that. So let's have a quick look at a few of the other common options in the hole wizard. So if we select the hole wizard again, and let's select straight tap. So this is going to be a threaded hole or a tapped hole, and again you've got lots of different standards that are all stored inside the hole wizard. I think for this one we'll use ANSI metric again. If possible, it's always good to use a single standard within a company or within a set of drawings. It's not good to jump around in lots of different standards. Sometimes it's unavoidable, but generally if you can try and stick to one standard, it tends to make life a little easier. So we'll select an M5 by 0.8 pitch, ANSI metric, bottom in tapped hole. These won't be bottom in because we're going to go all the way through the side, so I've changed that to tapped hole. We'll define a position, so we'll just put 2 of these on this side. And some of the options that you get in the tapped hole are, you've got the depth of the hole, which by default is to the shoulder of the drill that's going to create it. So you can see that in this little preview. It's not to the tip of the drill, it's the shoulder of the drill. And again, it's given us a little preview of that. This is far too deep. If we want to just get through this side, we can set that, in this case, at 7mm. And then this next one is the tap depth, so the depth that you're going to instruct someone to tap the threads on this. Now what it tries to do is calculate the tap thread depth with regard to the drill depth that you've entered, but it's also linked into the diameter of the hole. So the fact that the diameter of the hole is 5, it's trying to maintain 10mm as the tap depth here, but we can override that if we want. In this case, seeing as we break through and there's no more material beyond the wall, we can set these at the same level. Normally you would take the drill depth to a certain value more than the thread depth, at least a couple of mil, maybe more. So if we click on OK, and you can see we get a preview that it's a tapped hole. We've got a tap texture in there, and then we've got this outer diameter of the hole threads there as well. And the thing to note with these is you could create this geometry by doing an extruded cut. So you could draw a circle on these outside faces and just extrude cut the circle through, but that these features have a little bit more intelligence built into them. For the first thing, they're labelled as whatever standard they are in the feature tree. So this one's labelled as an M5, this one's labelled as a 5mm diameter hole. And another nice thing is that you can use those standards when you're creating drawings of the part, so you can pull that information directly out of this feature. The fact that it's an M5 ANSI 0.8 pitch tapped hole, so it adds a little bit more data in there than you would get if you just simply extruded cut through here. So it's always good, certainly on threaded holes, it's good to use the hole wizard, and certainly on drilled holes up to a certain diameter that would be practical to drill rather than cut in some other method.